It's my page 3. I'm going to copy the problem. Log x plus log x plus 15 equals 2. The domain has to be stated only on the raw equation. Don't touch, don't do anything, don't condense, don't expand, don't do anything, nothing. We have to state the domain. If we choose this method, we have to state the domain on the raw equation. Okay. So we start with this function. What is the domain of this function? And you already told me the domain for log x. So the domain is x greater than 0. Okay, so from here we have x greater than 0. Now let's look at the other one. How do I state the domain of log of x plus 15? Log base 10 of x plus 15. What do I have to state? Don't solve anything, just tell me what to write for everyone to see first. What should I write for this function in order for it to exist? It's okay if you're wrong, we have to communicate, please. Kevin, Zach, is anyone with me here?
Would you write plus 15?
But I have to state a restriction. What restriction do I have to state? Yes, I see Charles wrote, but I said do not solve it yet. So x is the quantity that we apply log to. X has to be strictly greater than 0. X plus 15 is the quantity we apply log to. X plus 15 has to be greater than 0. Now, since we have two functions, we have to intersect the restrictions. Can anyone tell us what will the intersection be from these two? So we can graph them. That's the easiest thing to do. I will graph greater than 0. Oh, it's already there. And I will graph x greater than negative 15. And it's right here. And we have to choose the intersection of those two, orange and black intervals, because we want both functions to exist at the same time. What is the intersection of those two, orange and black?
0.
The intersection. This is one territory, this is another territory.
Greater than 0.
Exactly. So then the domain is indeed 0 to infinity. When I am done and when I solve the equation, I will only pick here. Only pick here. Any other solution will be disregarded. Any questions? We already know how to condense this. How do we condense it? Can anyone tell us how to condense log x plus log x plus 15? We reviewed those properties a few minutes ago.
Would it be x times x plus 15?
Correct. But that's not enough.
Oh, equal to 2.
Careful. So let's go back. Let's go back to the property. Log, so the property as you just mentioned, actually I should have mentioned this myself. So these are dynamic, right? In the sense that from here I can get here, from here I can get here, from here I get here, and so on and so forth. So now I have this situation. What do I have to write? I'm here, and I want to write this.
Log whatever I just said in parentheses.
Yes, of x times x plus 15, you can put it in brackets, equals 2. I completely agree. Good. Now, one of the most important conversions is a log. Let's start with log, because I have a log here. any log equation can be replaced by an exponential equation and vice versa. But we have to remember how. So log base A of x is y is equivalent to, can anyone tell us what to write? Log base 10 of something equals a number that is equivalent to base, counterclockwise, base raised to this number equals this. How do I write that?
For our problem,
Yes.
it would be 10 squared equals x squared plus 15x. Sorry.
Excellent.
So
10 squared.
what's in the parentheses basically equals what's in the log.
You mean here? So this is x squared plus 15x. So 10 squared, which is 100, equals x squared plus 15x. I'm losing my voice. Sorry. Do we all agree with this step? We cannot continue before you.
Again, 'cause I somehow don't remember what I think.
Okay, so log base A of x equals y is equivalent to A raised to y equals x. The base raised to this equals x. The base raised to this equals this.
Oh, okay, thank you.
Thank you. 10 squared, 100 equals x squared plus 15x. Do we all agree with this step? Any questions on this? Anyone, please? If we understand this step, we can continue. Don't be shy. Okay?
I'm good.
Good. What type of equation is this? What do I do?
It's a quadratic.
Yes. X squared plus 15x minus 100 equals 0. Can anyone give us the factored form and the two solutions? I'll get a cough drop. Nothing is more annoying than somebody coughing in your ear. Sorry about that. So, can anyone factor this for us and give us two solutions?
X plus
X
5,
plus-
x minus 20.
Careful, I'm gonna
Oh,
write
yeah.
it.
Other way? Oh,
Remember,
x plus 20, x minus, and then it would be negative 20 and then positive 5.
so 20 minus 5 is indeed 15, and the product is good. So you have negative 20 and 5, and I'll say not so fast. What am I referring to?
One of the equal negative 20.
That's the reason why we stated the domain from the very beginning. This is okay, is in the domain. This one is not. So again, the bottom line, be careful with these three functions. Equations, expressions, no matter what. Be very careful. Good. I think we also chose 25. Let's work on 25 and then move on. Sorry. Good. So 25, what was it? Natural log x plus natural log of x plus 2 equals 4. I'm sorry, I'm not sure why I'm losing my voice. This is extremely similar to what we just looked at. I hope you see that, right? What is the domain of this? Anyone, please?
X bigger than 0.
Good. And here? There is no difference, really. Okay. Same idea. This is greater than -2, greater than 0, so the domain is exactly the same. You're going to tell me exactly the same thing. X squared plus 2x equals 4. Can anyone give us the equivalent form? Equivalent exponential form. Anyone, please? Exactly how we stated it before. Nothing different. Just the base is different. Anyone, please?
E to the 4th equals x squared plus 2x?
Yes. So we have x squared plus 2x minus e to the 4th equals 0. Okay, yes, we can use the quadratic formula. No, we cannot factor. But remember we discussed one option under apps, number 9. It's quadratic. It's degree 2. The leading coefficient is 1. The middle coefficient is 2. And the last coefficient is negative e to the 4th. Okay? So we got one solution, approximately 6.4564, and the other solution, negative 8.4564. Not so fast. What is our final answer? Anyone?
It can't be the negative.
Absolutely. It's not in the domain, but this one is. Any questions? Any questions?
Can you show how to enter it into the calculator?
Absolutely, yes. So you click on apps, select number 9, select polynomial, select the order, which is the degree, in our case is 2. Click on graph, and you have to enter the coefficients in descending order exactly as you see them. 1, 2, and negative e to the 4th power. And then graph. 6.4564, negative 8.4564. Again, if you don't state the domain, you're obligated to go back in the original problem and check both. Choose the method you like. I'm lazy, I prefer to state the domain, I don't like to go back and check. But you decide. You don't have to be consistent, as I said, but you must choose one or the other at all times. Good. I would like us to continue, and as I said, we'll come back to other problems, but I would like to talk about the difference quotient now. Whenever I talk about the difference quotient, I have to start by talking about the average rate. Of a function between 2 points. Sorry, I'm not sure what's happening. And when we do that, after that, we're going to get to the difference quotient. I don't like just say, find the difference quotient. I like to explain what it is first. But we have to talk about the average rate of change, the average rate of change of a function between 2 points. So here's a function. Here's our f of x. And let's say we have 2 points. I have point A and I have point B, and they do have coordinates x1, y1, or f of x1. I hope everyone is in agreement with that. So let's say x2, and of course there is a y2, but I prefer it as f of x2. I don't think that this is very clear. F of x2 and f of x1. Imagine that we draw a secant line through those 2 points, and the secant line has a slope. So the slope of AB. Can anyone refresh our memory on how to determine the slope of a line passing through 2 points?
Isn't it the y1 minus y2 over, or flip it, but x1 or x2 minus x1 over y2 minus y1?
Excellent. I'm going to write as f of x2 minus f of x1 over x2 minus x1. Excellent. Who was that?
Malaika?
Malaika. Thank you so much. Excellent. Of course. This is it. So imagine that I go from Baltimore to New York, and you ask me what was your average speed, and I will say, okay, I have the time frame, I have the 200 miles, so I have the distance, I have the time, I'll divide the distance by the time that I needed to get from point A to point B, and that was my average speed. Okay, so that's the average. The slope of AB is nothing else but the average rate of change of a function between these 2 points. So the average f of x between x1 and x2. Keep this in mind for a moment. And now let's talk about something very important for calculus, and that is my page 5. Let me start a new video 1 second.